You did it again. You told yourself just one. One piece, one bite, one square of chocolate, one handful of whatever was sitting on the counter. And then, without really deciding to, you had another. And another. And somewhere between the second and the fifth, your brain stopped counting. This is not a willpower problem. It is not a character flaw. It is not a failure of discipline or self-control or motivation. It is something far older, far stranger, and far more powerful than any of those things. It is evolution doing exactly what it was designed to do. And once you understand what is actually happening inside your body when you taste something sweet, you will never see that craving the same way again. Here is where it starts. About 2 million years ago, your ancestors lived in a world with almost no reliable food. Calories were not abundant. They were hidden, scattered, seasonal, and dangerous to obtain. Your ancestor did not walk to a refrigerator. They walked miles, sometimes days, hunting and foraging through environments that could kill them. In that world, finding something sweet was not a pleasure. It was a signal. It meant, eat everything you can right now because this might not be here tomorrow. That signal is still running inside you. It has not been updated. Evolution does not move at the speed of grocery stores. Neuroscientist Kent Berridge at the University of Michigan spent decades studying what actually happens in the brain when you eat sugar. What he found changed how scientists think about craving entirely. Berridge discovered that the pleasure you feel when you eat something sweet and the drive that compels you to keep eating are two completely separate systems in the brain. The pleasure is handled by opioid circuits. The wanting, the compulsion, the pull toward more, that is driven by dop. And here is the critical part. The dopamine system does not turn off when you are satisfied. It ramps up. Think about that. The more you eat, the more your brain wants. Not because something is wrong with you, because that is exactly what survival required. Dopamine, as most people understand it, is the reward chemical, but that is not quite accurate. Dopamine is not the chemical of pleasure. It is the chemical of anticipation, of seeking, of not stopping. When Berridge and his colleagues blocked dopamine in rats, the animals stopped pursuing food entirely. But when they were fed directly, they still showed signs of enjoying it. They would lick their lips. They would swallow. The pleasure was intact. The wanting was gone. Two systems, two separate experiences, both firing when you open that second bag of chips. And sugar hits both. The sweetness activates your opioid circuits and produces a brief, real, measurable sense of pleasure. But it also floods your nucleus accumbens, the core of your brain's reward system, with a dopamine spike that tells every part of your brain, this matters, find more of this, do not stop. Researcher Bart Hobel at Princeton University demonstrated in a series of studies that rats given intermittent access to sugar showed all the behavioral patterns of addiction. They binged. They showed withdrawal symptoms when the sugar was removed. They worked harder and harder to get access. And when he gave them drugs known to trigger cravings in humans, the rats relapsed specifically to sugar, not to other foods. Hobel called it sugar addiction, and it was deeply controversial. It still is. But the neurological mechanism he identified has held up. Your brain does not experience a candy bar as a food. It experiences it as a jackpot. Now add another layer. Your body has a hormone called leptin. Leptin is produced by fat cells, and its job is to tell that the hunt was successful, that you can stop. When leptin is working correctly, it acts like a volume dial on your hunger, slowly turning it down as your fat stores fill up. But researchers at the University of Washington found something alarming about what happens to that system when you eat high amounts of fructose, the type of sugar found in almost everything processed. Your brain stops hearing leptin. It is not that the hormone disappears. It is that the brain becomes resistant. Signal is there, the brain ignores it, and so your hunger dial never turns down. You keep eating, and you are not broken. Your ancient brain simply does not believe the signal, because in the ancient world, that signal never needed to be resisted. There was no food engineer designing something to trigger every reward pathway in your brain simultaneously. There were roots and berries and honey stolen from hive once a season. Now consider what modern food is actually built. Food scientists have a term, the bliss point. It was first identified and named by market researcher Howard Moskowitz, who spent decades being paid by major food companies to find the precise combination of sugar, salt, and fat that maximizes human desire without triggering fullness or satisfaction. Not pleasure, desire. The goal is not to make you feel good. The goal is to make you want more. Moskowitz found that each person has a response curve to sweetness, a level at which they rate something as most pleasurable, beyond which it becomes too sweet and below which it feels flat. His job was to engineer every product to hit that curve perfectly, for the maximum number of people, every single time. The food in your kitchen was designed by people who understood your dopamine system better than you do. And your brain, running software 2 million years old, has. But here is something even stranger. A 2013 study published in the journal Current Biology by researchers including Stephanie Borgland found that your brain physically changes when exposed to high-sugar diets over time. The prefrontal cortex, the part of your brain responsible for long-term planning, decision-making, and saying no, loses gray matter density. It shrinks, not dramatically, but measurably. The part of you that can override the craving becomes physically smaller while the part driving the craving becomes more entrenched. Your ancestors never needed a prefrontal cortex strong enough to resist a Krispy Kreme. They needed one strong enough to plan a hunt. Those are very different cognitive tasks. So what actually happens when you decide you are going to cut sugar out? Your dopamine system, deprived of its expected spike, triggers a drop in baseline mood. It is a measurable neurochemical event. You feel irritable, flat, foggy. Researchers call it anhedonia, an inability to feel ordinary pleasure. The same state that occurs in the early stages of withdrawal from other dopaminergic substances. Your brain is genuinely in a kind of withdrawal, recalibrating receptors that had come to expect a signal they are no longer receiving. This is why every resolution made on a Monday morning falls apart by Wednesday afternoon. You are fighting a neurological storm using only your conscious mind, the weakest and most recent part of your brain, against systems that have been refined over millions of years of survival pressure. And this is also why the solution, when it works, almost never looks like willpower. What the research suggests works is something more structural. Remove the trigger from the environment, because your dopamine system begins firing not when you eat the sugar, but when you see or smell the thing that predicts it. Exposure alone is enough to spike wanting. Studies on habit formation by Anne Graybiel at MIT show that behavior driven by the basal ganglia, deep, ancient, automatic circuitry, becomes progressively harder to interrupt as the habit strengthens. But it can be interrupted at the cue stage before the craving fully fires if the cue is removed or replaced, not resisted, rerouted. Your brain is not punishing you. It is protecting you, or it thinks it is. It is running a 2 million-year-old emergency protocol in a world that no longer has the emergency. Tonight you might find yourself standing in front of the open refrigerator, not quite hungry, looking for something you cannot name. You will reach for something. And now you will know exactly what that feeling is. Not weakness, not failure, just an ancient brain doing its ancient job, searching for calories in a world it was never built for. The craving is real. The hunger is real. And so is the part of you that can, slowly and imperfectly, learn to recognize the signal for what it actually is. Not a message from today. A message from 2 million years ago.